Hi, in today's video I'm going to be covering a major breakthrough I've made on FreeBSD. I've managed to get ffmpeg nvenc encoding working in a Rocky Linux Podman container running on FreeBSD. And the user in the Podman container is a non-root user. It's a regular user, and I've actually managed to get nvenc encoding working. So what I have here is a set of ffmpeg Rust scripts that I wrote that are available for Mac, Windows, Linux, and FreeBSD. And they have support for nvenc encoding on Linux and Windows. And if we actually have a look at some of the code down here, what you'll see is that it actually performs a OS check as if you're running on Linux, and it checks if the dev-nvidia-ctl file exists, and if it does, it will then use hardware encoding. What I'm going to do is switch across to the terminal, and what I've got here is I'm inside the Podman container, and what I have done is mounted a directory from the FreeBSD host into the container, which contains a video file. And I'm now going to press return here. And you see hardware acceleration, using hardware acceleration, okay, is now created a clip. If I switch back to the FreeBSD side, I can now copy that file that's just been created from the mounted directory. So we've got a mount directory on FreeBSD that is mounted into the container, and I have just processed a video with hardware acceleration encoding using ffmpeg and CUDA. And if we have a look here, we can now see the file. If I run ffmpeg-i and the file down here, what you'll see is video hevec, and I can now play this file. So you can see down here hevec nvenc. Okay, so I can now play this file, and this is a 10-second clip that I've just created. Okay, and so the other important thing is that the file that was created in the Podman container has the same ID as on the FreeBSD host. So you can see that it is actually owned by my user on FreeBSD. So what I'm going to do is actually take you through how I managed to get this set up. And the important thing about this is this proves that getting CUDA to work in a Linux Podman container on FreeBSD is possible. And what this does is this means that we should be able to utilize this for other applications as well. I'm going to take you through the steps I've taken to actually get this working. So there was quite a few issues I had to overcome to get to this stage. So if I come across to etc. devfs rules, actually what I'll do is I'll show this got better syntax highlighting if I show it in here. So what I have is what are called devfs rules. Okay, so these are the local rules, and what you can do is actually change the permissions on devices, and then in a separate rule set you can unhide those devices for the Podman container. So what we have here, for instance, is add path NVIDIA mode 6660 group video. And if we come across and have a look, ls dev nvidia wildcard, what you'll see is that these devices are owned by root and video, and what you'll see here is we've got user, group, and other. Okay, so the issue I had to overcome was I could actually get hardware accelerated video processing working, running as the root user in the Podman container, but obviously you don't want to run as root because that means we can't run GUI applications and things like that. So the issue was that the NVIDIA drivers were actually showing up as owned only by root and didn't have group permissions, so only the owner, root, had the permissions to actually use the NVIDIA driver. So what I found was by changing the permissions here to mode 666 and group video, that changes the permissions on the FreeBSD host. What we then have is this second devfs rule set, jail4. And what this is Podman containers are actually jails, they're OCI jails. And what you can do is actually create devfs rules that apply to the Podman containers. And the devfs rules have an ID. So you can see here, devfs rules jail4. And this is actually the devfs rules that are applied to the Podman container. What I'm doing is actually unhiding several things like the mixer, ESP, NVIDIA, and speaker. Okay. So the next step is what I have here is the directory that I've actually been using. So what we have here is, ignore the git ignore, and we have a bin directory, a compose.yaml, and the dummy-uvm.so. SMT. So the bin directory is actually all my ffmpeg Rust scripts built for Linux with the nvenc support. Okay, and the dummy-uvm.so is a file that we build and actually add to the container and preload. And what this does is we don't have a UVM, NVIDIA UVM file or device on FreeBSD. And what this dummy-uvm.so file does when it's added to a jail or a Podman container is it actually intercepts the NVIDIA requests for that device and sends them to dev null, I believe. And this is critical to actually get the NVIDIA card working. So what we have here is the compose.yaml file. So the way that this works is, if I go through the steps, we have a compose.yaml file. And first of all, what we actually do is we pull down a Rocky Linux container, which is Rocky Linux 9.3, which is actually the same version as is used by the FreeBSD Linuxulator. So when you enable Linux support in FreeBSD in your, is it your acclerated rc.conf, yeah, Linux enable. When you do that, that's what enables the Linuxulator, and this translates Linux syscalls from Linux to FreeBSD on the host. So what we're actually doing is we're using the exact same version of Linux in the Podman container as is in the FreeBSD Linuxulator. So what you have to do is you pull down the Docker image for Rocky Linux 9. Let me just come across to my notes. Okay. I need to update these, but what you do is when you pull the Rocky Linux container, you run doas podman pull --os linux, and the path to the Rocky Linux 9.3 Podman container on Docker.io. Well, that pulls down the image, and this OS Linux is essential because otherwise it's going to throw an error. So once we've actually pulled down the image, what we do is we create this compose.yaml file. And this is a set of instructions on how we're going to actually build using that image that we've just pulled down. So I'll take you through the important steps up here. What we've got here is services, and then we're calling this GPU app. And we've got the image here, so image Rocky Linux 9.3, which is what we pulled down. The platform we have to specify as Linux AMD 64. We've got the container name, so we're calling it Rocky ffmpeg. We're specifying OS Linux, and we're setting network host. And basically what that does is that uses the host's networking to actually get everything working. You can use, I have Unbound set up, which is a recursive DNS server that I showed you in a previous video, running on FreeBSD. So it's actually using my DNS server for the networking. We have stn open equals true and tty equals true. And this allows us to actually enter the container by running doas podman exec. Now this is the interesting part, the volumes. So what we're actually doing is we have compat Linux user lib64 on FreeBSD, which is the Linuxulator. This has all the libraries for the Nvidia drivers, and there are lots of different libraries. So what we're actually doing here is, if you look at these paths, we've got compat Linux user lib64, user lib64 nvidia-host read-only. What we're doing is we're mounting the entire compat Linux user lib64 from FreeBSD with all the libraries to this location inside the Podman container, user lib64 nvidia-host. And the reason why we're doing it this way is because we're actually creating an additional set of libraries inside the Podman container. So rather than sort of mounting the libraries from FreeBSD's Linuxulator over the Podman Rocky Linux libraries, we're leaving the Rocky Linux libraries intact, but creating an additional directory full of libraries from the FreeBSD Linuxulator. Okay. What we have here now is we have got the NVIDIA SMI mounted from FreeBSD to the same location in the Podman container. And what we're doing on the next step is the dummy-uvm.so file, which we actually built using the Podman container. Basically, we have a file, a C file that we compile with GCC, and this creates the dummy-uvm.so file. And what we're doing is we're taking it from the current directory on FreeBSD and installing it into the Podman container at user lib64 dummy-uvm.so. It's got read-only permissions here. Right. So this is the file that actually intercepts the NVIDIA calls to the non-existent NVIDIA UVM on FreeBSD and redirects them. What we have next down here is, you can see we've got bin and mount. And what we're doing is we're actually creating a user in the Podman container called Podman, who will have a home directory at home Podman. What we're doing is we're actually taking the, I'll show you in mount, ls Podman. Let me do that long listing, makes more sense. Podman Linux. So this is where the compose.yaml file, the dummy-uvm.so file, and the bin directory are. And the bin directory, as I said, is all my ffmpeg Rust scripts built for Linux. Okay, what we're doing is we're mounting that bin directory full of scripts into home Podman bin inside the Podman container, and this allows you to run those scripts from within the Podman container. Okay. Then what you'll see is ~/mount home podman mount, and what that does is that's taking the mount directory from FreeBSD and mounting it to home podman mount in the container. So what this means is, if I come into mount here, so this is on FreeBSD. If I do touch new file, okay, and I switch across to the Podman container, so I'm inside the Podman container here, inside home podman mount. If I now run ls, you'll see that new file is showing up. So what we were doing is mounting a directory from FreeBSD into the Podman container, and this allows us to actually transfer files back and forth. Okay, so when we process video files in this mount directory inside the Podman container, they show up on the mount container, the mount directory on the FreeBSD side. And what you'll notice is, you see here, it's an empty file. In the mount container, the mount directory inside the Podman, you'll see they're owned by Podman. If I switch across here, okay, what you'll see is my username. So they're owned by my username here. If I run ID, you see I have an ID of 1001. If I switch across here and run ID, you'll see that this Podman user has got the same ID and group ID. And this allows the files to be owned by my user when I copy them out of the mount directory. Does that make sense? So when I created this file here, they're called Podman, but this Podman user has the same UID and GID as my user on FreeBSD. So that means that the files will have the correct permissions and won't be owned by root or anything on FreeBSD. Okay, so what we're doing, as I said, we've copied the bin directory, we're mounting the mount directory, and then what you see here is when you create a jail on FreeBSD, what you actually do is you mount specific directories from the host into the jail. And so what I've done is actually taken the work that I did on let me come up. Profile. Oh, wrong thing, hang on. Okay. So this is how I got DaVinci Resolve working in a FreeBSD jail. So what I've done is taken the knowledge that I acquired during that setup and applied it to the Podman containers, because essentially they are jails, the OCI jails. So what I'm doing is actually using the same techniques I used for the jail for the Podman container. I swear these clipper lighters are getting worse. Yeah. So what I'm doing is actually mounting compat Linux proc to proc. So we're mounting compat Linux proc from the FreeBSD host to proc inside the Podman container. The same with compat Linux sys to sys, compat Linux dev to fd to devfd. Then you'll notice this Rocky shim dev shm, and that's at the bottom of the file, and I'll get to that. So what we have down here is the library path. So the default library path is going to be user lib64. And then what we've got here is the path. So we're actually setting the path to include home podman bin. So it picks up the bin directory that we have mapped from the FreeBSD side into home podman bin, which is where all scripts are. With me so far? So what we've got next is this entry point. And what this is doing is this is running a command. And what we're doing is we're echoing libuser64 dummy-uvm.so into etc ld.so preload. And what this basically does is this preloads the dummy-uvm.so file into the system so that it's aware of it. Next, what we're actually doing is we're actually creating groups that match the permissions from FreeBSD to the Podman container. So you've got an etc groups file which tells you what groups you're in. So that's what you've got here, groups. You see I'm in Podman, root, wheel, video host in the container. Groups, wheel operator, video, username on FreeBSD. So the groups files okay, so this is the FreeBSD group. So you can see I'm a member of wheel, which is 0, root, my username, operator, and video is 44 here. Okay. So if I switch back to the Podman container, etc., groups, less groups, you see what I am. I'm root. Podman is in the root group. In wheel, it's in video, which is listed 39 here, and then we've got this video host. So what happens is on FreeBSD, the Nvidia. So the Nvidia drivers on FreeBSD by default run by root. What I did was, as I showed you with the devfs rules, is set them to be owned by root and video with permission 660. So that enables the video group to have access, right? But the video group on Linux is 39 and on FreeBSD it's 44. So what we're actually doing is we're creating a group with the GID of 44 and we're calling it video host. So that corresponds to the video group ID on FreeBSD, which has access to the Nvidia drivers. Next, what we're doing is we're creating a group with a ID of 1001 called Podman, and that corresponds to the group ID of my user on FreeBSD. And this is what allows the files that are created to have exactly the same permissions because they have the same GID and ID as on the FreeBSD host. Yeah, so that when we create files inside the Podman container, they will have the correct permissions on FreeBSD as our user. Right. Next, what we're doing is we're doing user add 1001. So we're adding the Podman user to the group 1001, the user 1001, the group 1001. And what we're doing is here you can see we're doing group 0, 10, 39, 44. So that's root, that's wheel. This is the video group in the Podman container. And this 44 is this video host group that we have created with the GID that matches the GID of the video group on FreeBSD that has permissions to use the Nvidia driver. Okay. So next what we're doing is we're actually copying the default bash rc and bash profile. So what you have is what's called a skeleton. And what this is this is a sort of default bash rc setup. And what we do is, because we created the directory in a previous step, the user in a previous step, we actually have to copy the default bash rc and bash profile to home podman bash rc and bash profile. Next, what we're doing is we are echoing the ld library path. And what this is important. So we've got the user lib64, which is the default. But what we're doing is we're actually appending the user lib nvidia-host library path to that. So this section here is what, yeah. Okay. So remember I said we've got compat Linux user bit, where is it? No, here. Compat Linux user lib64, okay? LSL, what was it? Compat Linux user, Compat Linux user lib64, okay? So this is this is the Linuxulator directory on FreeBSD. And what you'll see here is all these NVIDIA libraries here. So the important thing that you'll notice is a lot of these are symlinks. So this is like a symlink to this is a symlink to that, and etc. So we don't want to try and map all of these files individually, right? So what we're doing is we are mounting that entire directory into userlib nvidia host inside the Podman container. So what this does here is we're setting the ld library path where it's going to look for libraries in the Podman container to the default, which is user lib64, but then we are appending to that library path user lib64 nvidia host, which is the Linuxulator libraries that contain all the NVIDIA libraries to this location. So what it does is it means it's not going to interfere with the default libraries installed in Podman. It's just an extra place where we can actually look for libraries. So I said the interesting thing about this technique is we got no NVIDIA driver installed in the Podman container. It's purely using the Linuxulator NVIDIA libraries from FreeBSD mounted into the container. And the important thing about this is the issue with creating a jail and getting that to work with CUDA is that you actually have to install exactly the same NVIDIA driver in the jail as is on the host, and you have to do it manually. And if you upgrade the NVIDIA driver on FreeBSD, you then have to upgrade the driver in the jail as well. So this gets around that completely. This basically means that whenever you update the NVIDIA driver on FreeBSD, Podman will pick up the new drivers. Or T. Then what we're doing is we're also echoing ld preload userlib dummy-uvm.so, which we've actually, you come across back up here. You can see this bit where we're setting up the GPU shim. We were echoing that into that location into ld.so preload. But just to make doubly sure, what we're doing is we're actually using ld preload inside the bash rc. So that sets it as an environmental variable in the shell for this user. Then what we're doing is we're echoing path equals path and appending home podman bin, which is the bin directory. I come across here. Podman. So this is the bin directory here, okay, full of all my ffmpeg Rust Linux scripts with nvenc encoding enabled. So as I said, switch back. Yeah. So what that's doing is that's setting the path and appending home podman bin so that when you run a command in the terminal inside the podman container, it can see all the scripts. Now, the next thing we actually have to do is we're actually chowning the permissions. So by default, because we're using rootful podman, meaning that we have to run it with root, what happens is the home podman container is actually owned by root. So after it's created, what we're doing is we're chowning the permissions on the home podman container, and we're not doing this recursively with the -R option. We're changing the permissions on home podman to be podman, and then we're also changing the permissions on the home podman.bashrc and .bash profile so that they are owned by the podman container. Next, what you will see is how we install ffmpeg. So what we're doing here is we're running dnf install -y, so it accepts all the prompts. And on Rocky Linux and Fedora, what you have to do is actually use what are similar to PPAs on Ubuntu, and it's basically a repository that you add that adds additional packages that you can install. So by default, Rocky Linux and Fedora are quite restrictive about non-free software and codecs and things like that. So what we're doing is we're actually installing these extra repositories here, so you can see free and non-free, that we can install ffmpeg from. And what you'll see down here is DNF configure manager set enabled CRB, and this is required to actually get those repositories to be picked up. What we're then doing is actually installing ffmpeg, and I was installing which isn't required, but in my debugging I was having issues with ffmpeg being picked up. So this was allowed me to actually find the correct location of ffmpeg. Then finally, almost finally, what we have down here is bin bash. And what that does is when we run doas exec podman, and let me show you. So what we do is once the compose.yaml file set up, we run podman compose up. And what you have to do is you actually have to wait for it to download everything, you know, ffmpeg and everything. So what we do is we actually run, let me just show you this again. So doas podman compose up -d, what I mean is detach, so it sort of puts it in the background. What we then do is run doas podman logs -f rocky -ffmpeg, which is the name of the container, and that shows us the progress of ffmpeg being installed and everything being configured. Once that's then done, we can actually enter the podman container by running doas exec it-user podman rocky ffmpeg, which is the name of the image, and then bin bash, so that it gives us a shell. So that's why we have bin bash down here. And then finally what we have is volumes rocky s-shm, and that corresponds to the volume section here. You can see we've got environment, we've got volumes, we've got rocky shim devshm, and what that is that's tempfs. Okay, so this is a tempfs directory, and that's needed to get everything working. So once we've entered the container, as I said, that puts us at a prompt like this. And so, as I said, I can cd mount and that is the mount directory from FreeBSD with the video in it that we've mounted to the Podman container with the video in it. Okay, so let me just remove the first one, and I'll do this again. So this is the trim clip script -h, okay, and I have the FreeBSD version here, so trim clip -h, okay. However, the reason why I want to test this is because FreeBSD natively does not have CUDA support. So the issue I was facing was I could sort of port all my Rust scripts to use Vulkan. However, that's really difficult because it's not a simple matter of just changing a few commands. You've actually got to do this stuff where you have HW upload and HW download, where you've got to upload the pixels to be processed to the GPU and stuff like that. So that wasn't going to be an easy job. So what I've now got is the ability to run my Linux version of the ffmpeg Rust scripts that have nvenc hardware acceleration support in a Podman container on FreeBSD. So here is the script. So what this allows us to do is actually trim a video by specifying a start time, an input file, and the number of seconds after the start time. So what I can do is I have two versions of this script. Trim clip, which takes a start time and the number of seconds after the start time. So for example, 00:00:00 is the start, and you can specify the T option with 00:00:10, and that would record for 10 seconds. If I have trim clip 2-h, what this does is it allows you to specify a start time and an end time instead, because suppose you're trimming from something like 1 minute 37 and you want to record to 1 minute 57, you can specify that 1 minute 37 and 1 minute 57, as opposed to the other script where you would specify 20 seconds. Does that make sense? What I'm going to do is trim clip 2, start. I'm going to do hours, 1 minute. Okay, input, and then let me just check, get my own scripts, 2, 1 minute and 30 seconds. Now what I can do is I can optionally provide a -o option and an output file name, but if I don't, what it's going to do is actually default to creating an output file name, the input file name with the start and end times in the file name. Using hardware acceleration, glad it didn't fail here. So it's now using CUDA, using the GPU from FreeBSD, all the libraries mapped from the Linuxulator into the Podman container to use ffmpeg nvenc encoding in the container on FreeBSD. Make sense? So I can now see that file. Again, you can see it's been created here, and what you'll see here is it has appended the time, so from 1 minute to 1 minute 30.mkv, and this is useful because it allows you to create process files and actually know what bit of the file you've processed. So what I can do now is switch across to the mount container on FreeBSD, and you will see the same file exists here, and it is owned by my user, so there's no permission errors because it's using the same ID and GID in the container as on the FreeBSD host. And I can play the video. Bob's your uncle.
Is it usually this?
We've got a 30-second clip here, as you can see. And if I come across here and pause this, H26, there we go. High efficient video, main, VAPI, audio. Yep. Okay, and if I run ffmpeg-i, give it the file, bang, what you'll see down here in the output is stream 0, stream 1, so this is the video stream, HEVEC, 24 frames, AAC, so that is pretty darn cool. We have got something that is not possibly natively on FreeBSD, and that is ffmpeg hardware encoding using nvenc. There is the nv-sgl run script you can use on FreeBSD to prefix the ffmpeg command, but the issue is what frequently happens is there'll be a mismatch, there'll be some error, the drivers will be updated and the shim's not been updated and it'll stop working. So we completely eliminated that issue. So basically what we have got here is, as I showed you in a previous video, if I come into, if I'm on the FreeBSD side and I run NVIDIA, hang on, NVIDIA SMI, what you'll see is its output without CUDA, right? If I run nv-sgl run NVIDIA SMI, that allows this shim here, this libc6.so shim, actually gets it to show up with CUDA. In the Podman container, if I run NVIDIA-SMI, bang, you will see we have got exactly the same output. Yeah, it's picking up CUDA. And remember, the mad thing about this is on Linux, what you have to do is you have to install the NVIDIA CUDA toolkit to actually work with, to get Podman containers working with the GPU. So we beat Linux at their own game. Yeah, we've got no CUDA support. We've got NVIDIA drivers. NVIDIA said, "Oh, we're not going to do NVIDIA CUDA for you. We're not going to do the NVIDIA toolkit for you. F you to NVIDIA. We'll do it ourselves. Come up with a little workaround and get CUDA working without any of that." And there you go. We've got CUDA working. We've got hardware accelerated video working with ffmpeg. And this was a really good first test. And I've run out of tea. Damn. I need a bigger cup. So yeah, this was a really important first test to actually get the video processing working. And as I said, let me just show you the LSL dev Nvidia in the Podman container. So you can see here, done by root, right? We've got user, group, and other, right? So what originally stumped me was I was using what are called devices in the Podman compose YAML file. And what happened when I did that was that the permissions on this were root, but only for the owner. And what that meant was that I could only get the hardware acceleration working as root. That's shit. Working, great. As root, that's limiting. So find the process that I've gone through and shown you in the video of using the devfs rules, the compose.yaml file, tweaking the groups. What this allows us to do is actually access the NVIDIA GPU on the FreeBSD host from the Linux Podman container running as a regular user. And that's critical because what we want to do is build on this and actually be able to install GUI applications, perhaps something like Firefox running with DRM capabilities for playing back encrypted content, like you have things like in the UK, you've got ITV and Channel 4, which use DRM for their videos, so you can't watch them without that DRM support. We do have DRM support for Chromium on FreeBSD, but as I said in an earlier video, the issue with using Chromium is that it uses a new manifest v3, which restricts add-ons such as uBlock Origin. So you've got uBlock Origin Lite on Chromium, whereas you've got uBlock Origin on FreeBSD. And the difference is that uBlock Origin Lite on Chromium will show you adverts. And that's pony. Yeah, we don't want no adverts. Yeah, we just want the video. So what we can do in future steps is hopefully get Firefox running with uBlock Origin. We can create a Wayland window. We can use a pulse audio socket. And these are things that I have done previously in a jail, so I know work. Okay, so I'm not speculating, this might be possible, this might not be possible. That is possible. Podman containers are jails. They're OCI jails. So we can use the same techniques that I came up with through my work on actually installing DaVinci Resolve in a Rocky Linux jail. And I know that there is a way where you can map the XDG runtime directory, which contains the Wayland socket, from the FreeBSD host to a jail. And what you can do is you can create a pulse audio configuration file that creates a pulse audio socket in the temp directory. And what it will be possible to do is mount those two files from the FreeBSD host to the Podman container, and that gives us video and audio. Yeah. So what we can do is actually create Podman containers that will be hardware accelerated, be running under a regular user. We'll have the ability to create a Wayland window and get the audio working with Pulse Audio. So you would start Pulse Audio on FreeBSD, and that will create the Pulse Audio socket, which would be mounted into the Podman container, which will be picked up by the application, and the audio will come out the FreeBSD side. Trust me, it works. I've done it before. I know what I'm talking about. Strange as it may seem, I actually do. So yeah, big breakthrough. As I said, I've proved that CUDA will work. Came up, showed you that yesterday. Took a bit of work and a couple of gallons of tea and a couple of packet biscuits. And that's what you need. That's the British way. At first you don't succeed, have more tea. Usually takes a gallon or two. When your eyes start going funny and you start seeing pink elephants, then you know you've hit the right optimum level of caffeine. But yeah, to recap, etc. devfs rules. I created a new rule here. So these are local rules. I created a new rule here for Nvidia. Change the permission to 660 and group video. Dev Nvidia. Okay, you can see root video 660, right? And that was the first step. The second step was creating the compose.yaml file, and as I said, we pull down the image. Remember when we pulled down the image, we specified --os Linux. Otherwise, it's going to say there's a mismatch. You're pulling down something. You're pulling down a Linux container, but you're on FreeBSD, and it won't work. So we pull down the Rocky Linux image, and then what we're doing is we're actually specifying here in the compose.yaml file, okay, use that image we've pulled down. We're setting the platform to Linux AMD 64. We're setting the OS to Linux. So we're saying your Linux, your Linux, your Linux, right? Remember that, your Linux, right? You're not FreeBSD, you're Linux. We're setting the network mode to host. So it's using networking from the FreeBSD host. Then we've got the volumes we're mounting. Again, we're mounting the entire compat Linux user lib64 with all the NVIDIA libraries to user lib nvidia-host. We are then mapping the NVIDIA SMI to the same location from the host to the Podman container. We are mapping the dummy-uvm.so file, and I'll just come back and show you that in my notes. Okay, dummy-uvm.so. So what we have here is this is the actual code for the dummy-uvm.so. And so what we do is we put that in the same directory as the compose.yaml file. And what we do is we build the dummy-uvm.so file inside the Podman container, and it saves it back into the same directory. Okay, so if I come to the Podman, you'll see the dummy-uvm.so file. And it's essential that this is built on the Linux side, okay, and not on the FreeBSD side, because otherwise you'd get an ELF error. You know, like that film with that funny chap that did Anchorman, whose name I forget, Will Ferrell. No connection, just thought I'd mention it. So what we're doing here is this is how we actually build the dummy-uvm.so file from the uvm_ioctl-override.c file. We're running, making sure we've got network host, OS Linux, and we're using the container, and we're installing GCC, and then we're actually building the file. And what it's doing is it's actually building the file, and it outputs it to the same directory where the compose.yaml file is. And lots of bits of this, I know your brain might be exploding at this point. Bear with me. So once we've built the dummy-uvm.so file, we are then installing it into user lib 64 dummy-uvm.so. We're then mounting the bin directory that we've got with the scripts and the mount directory from FreeBSD into the Podman container. We're mounting the Linuxulator JL essentials that are options that are used when you create a Linux jail. So what I'm doing is I'm thinking, okay, I know this works on a jail. Let's try the same thing on Podman. Kind of makes sense if you think about it. Then what we're doing, we're setting the library path, we're setting the path. We've got the entry point. So what we're doing here again is we're echoing the location of that dummy-uvm.so file into acclerated.so.preload, which preloads that module that is used to intercept the NVIDIA calls to the, it would be dev nvidia-uvm, which doesn't exist on FreeBSD. Okay, so what the shim does is it intercepts those calls and kind of tricks the NVIDIA processor. Oh yeah, I'm here, but don't worry, just carry on, forget about it. And then what we're doing is we're creating a group called video_host with a GID of 44, which is the ID of the video group on FreeBSD, which has permissions to use the NVIDIA drivers using the devfs rules. We're then creating a group called Podman with a GID of 1001, which matches the group of our user on FreeBSD. We are then doing user add, and we're creating the user with an ID of 1001, a group of 1001, which again matches the group on the FreeBSD side. And what we're doing is, because some of these things are owned by root, we're adding the Podman user to the root, to wheel, to the video group in Podman, and 44, which is the video host group on FreeBSD. So the important thing here, that I think this is the missing piece. And so we've got two video groups with different IDs on the Podman side and on the FreeBSD side. So on Podman, the video group is 39, and on FreeBSD is 44. And the NVIDIA driver has got permissions for the video group. What I found was just specifying group 44, which is the FreeBSD side, didn't work it through an error. I said, can't find CUDA OS error. Forget about it. So what I figured was, right, so if we add our user to the video group in Podman and the video group on FreeBSD, will that trick Podman into going, okay, you're in the video group and you've got access to the NVIDIA drivers on FreeBSD that I've got root and video. Yeah, with me? So that's how we create the user, the Podman user. Now, Rocky Linux does have a default user called Rocky, but what I decided to do is actually create a separate user, just so I could actually not have to fight against the system in case there were any special permission errors or anything with the default user. So then what we do is we copy the default bash RC and bash profile into the home Podman directory. And then what we're doing is we're echoing these variables into the bash RC, the LD library path. And again, this is the default path of the libraries inside the Podman container, is userlib64. And what we're doing is we're appending userlib64 Nvidia-host, which again, if you remember from up here, is from the FreeBSD Linuxulator running Rocky Linux 9.3. And we're running Rocky Linux 9.3 in the Podman container. So we've got maximum compatibility between the Podman container, the Linuxulator, and FreeBSD, right? So we're appending, we've got two library paths. We've got the default library path inside the Podman container where it looks at everything, and we're appending this other set of libraries from FreeBSD, which has got all the NVIDIA libraries, to that path. We can't, if we were just to replace the Linuxulator libraries over the Podman libraries, we would get errors. So what this allows us to do is have everything working normally, but then we can say, okay, using ffmpeg hardware encoding with nvenc, you look in these directories, oh, there's nothing there. But look over here. Look over here. Look in the NVIDIA host. Oh, there's the libraries. Oh, great. I can get on with the work. Then what we're doing is we're using LD preload to preload the UVM, even though we have set that up here. We're just making doubly sure. And this is the technique that I would actually use in the jail. And then finally what we're doing is we're adding the bin directory that we have mounted in the previous step up there to the path. So that's where all the scripts are, yeah? Those are the ffmpeg Rust Linux binaries with nvenc hardware acceleration support, so that when we type the name of the script in the terminal, it picks it up, yeah? We are then using chown to chown the home directory and the bash RC and the bash profile. We're not doing this recursively because we have mounted the bin directory and the mount directory from FreeBSD, and we don't want to, and they're mounted as read-only. And if we did that with the -R option, we would get errors saying read-only file system. So we're just changing the permissions on home Podman. I can show you here. ls home is owned by Podman. And again, this has got the same ID and GID as on the Freebsd side. And then what we do is we're running DNF, we're adding the repositories, enabling crib, and installing ffmpeg. And then when we actually enter the container, it's going to dump us into bin bash, and then we've got the tempfs volume down here. So the procedure that we actually go through, we pull the image. Once we've pulled the image, what we do is we run doas podman compose -up -d. That puts it in the background. You can't then enter the container straight away. What you need to do, as I said, is run doas logs -f Rocky ffmpeg, which is the name of the container. That will show us the progress of everything being installed, the user being created, and then once that's finished, we can enter the Podman container by running doas podman exec it-u podman user Rocky ffmpeg give us bin bash, so that dumps us at a shell. Then we change into the mount directory where the videos are. Bang, we can run the ffmpeg command, and it's going to use ffmpeg nvenc hardware acceleration encoding using CUDA and the GPU on the FreeBSD side. Not bad work. So made a lot of progress since yesterday. This took quite a bit of tea and biscuits to figure out. As I said, I originally got this working just with root, and that was great. I could run it as root with LD preload, LD library path prepended as a command, but that's no good. So back to the grindstone. Lots of tea and custard creams. And I finally figured out what the issue was. The issue was I was actually using the section here you can actually put in devices, and I was putting in devices and putting in the I was putting in these devices, the mode set, Nvidia 0 and Nvidia control. What happened was when I was using the devices option, as I said, they were all owned by root, but with read-only permissions for root. That's why the scripts are only working as root. Once I removed the devices options, I thought, do we really need them? But once I'd removed those, that and changing the devfs rules actually got to them to show up as owned by root and root, but with 660 permissions. Yeah. So what that means is that users in other groups, like the video group, could access the Nvidia driver. So that was the sort of major breakthrough. And also the major breakthrough was actually mounting the Linuxulator lib64 directory to a separate directory and then appending it to the LD library path. And that was another big sort of win, trying to figure out, you know, we can't overwrite the existing libraries because then we're going to get errors. So if we mount them to another directory and add that to the library path, would that work? And yeah, that was the other issue. We're loading the dummy-uvm.so, mapping that, doing all that. I've gone through this, so you should have got the idea of what I'm doing through going through this file and the actual commands that I'm running here. So now that I've got the nvenc encoding working, I proved the CUDA shows up with the NVIDIA SMI. That's great, but that doesn't really help us. Just showing CUDA, you know, you need to take it the next step. You need to get things working. You need to test it with something. and using ffmpeg with Linux binaries that are designed, as I said, so if I come in here, as I said, the libos, down here we've got this check, this hardware encoding check, yeah, that says, okay, as if the target is Linux and the path NVIDIA CTL exists, hardware encoding will be enabled. And if I come into the trim clip script, RST, yeah, okay, trim clip. Okay, let's go through this. So what you can see down here is it's using the hardware encoding function from the library, the librs file. And what we have got down here is actually a check. Okay, so what you'll see down here is we've actually got a check. If has encoder, right, there's a check in here to actually see, yeah. So you can see when I ran that command showing you the hardware, when I trimmed the clip, you wouldn't have noticed it said plus using hardware acceleration. Okay, so what this check does here is if you're running software encoding, it will print using software encoding. So I can prove that to you. So what I'm going to do is actually come back to the desktop. I'll remove that agent 365 and copy the mount agent 365.mkv to this directory. So what I'm going to do is I'm going to run the trim clip script. I've got the Freebsd version of the trim clip script installed here. So if I do trim clip /0 start time, give it the input file, 10 seconds, using software encoding, okay? So you can see there it's using software encoding. I'll just remove the new file and the trim clip. Using hardware encoding, hardware acceleration, and that's, you can, so that is the check here. So you can see here, if hardware acceleration is present, it's going to use nvenc with these options. Otherwise, it's going to fall back to using libx264. So if we now switch across here, do ffmpeg /i, look down here, you can see hevec, right? So you can see duration 10 seconds, stream hevec main. So that is the hevec main encoder. Whereas if I switch back here, ffmpeg -i, it should say lib. So there's an error. That's interesting. We have an error with that one. Ah, okay. So that script was actually failing on FreeBSD, which is interesting. I'm not sure why that is. I did think it went a bit quick. So you see here, look at the timestamps. I forgot to put 10 seconds in. My bad. So that's why it's the file was wrong. So if I come back up here, see the command I ran. So using software encoding. So you can see that takes a bit longer. Now if I do ffmpeg -i fingers, H.264. Okay, so you can see H.264 here. You can see hevec here. That's how we can prove, without a doubt, that the file that we created inside the Podman container is using nvenc hevec, whereas we can't do that on FreeBSD. As I said, sometimes you can get ffmpeg to work with the nv-sgl run command, but sometimes you can't. Drivers get updated, things get changed around, things need to be updated, and it stops working. Right? So what we got here is definitive proof, without a shadow of a doubt, that CUDA is working. We have access to the GPU running as a regular user inside the Podman container. We're doing something we can't do natively on FreeBSD. We're getting ffmpeg, hardware accelerated encoding, working with nvenc H.264. So, a lot of progress. And as I said, this was just to actually prove to you that this is all working. No chicanery, no sleight of hand, legit. So, yeah, it took a while to actually get to this stage, but because of my work over sort of several years ago, I really did this with the Linuxulator, and I did it with a Ubuntu jail and a Rocky Linux jail. I know what I'm talking about. I've done this before, and I know what's possible, and the tricks to actually get this stuff to work. Although, as I said, it does require large amounts of tea and biscuits to actually think these things through. And I use what I like to call the Lego approach. If you ever played with Lego as a kid, you get a box full of Lego and it's got a picture of something you can build on the front, but being a kid, you want to build something else. So you get all the pieces out on the carpet, loads of different blocks, and you try them all together in these different permutations. And so the blocks are equivalent to, in my way of thinking, commands, so that you're kind of putting different commands together in different permutations until you find the ones that actually fit together and allow you to build a spaceship out of something else that was, not what was on the box. So using that technique and sort of thinking a bit like Sherlock Holmes and the plumber, Basil Rathbone and Jeremy Brett. I still prefer Basil Rathbone, I think, because he was the first one I saw, but Jeremy Brett's fantastic. But that's another story. We're kind of trying to think logically about all the different permutations, how you fit things together, and drawing on past experience of using jails and what was needed to actually get that working combination of devfs rules and permissions. And the interesting thing is, with compose.yaml files, they work differently on FreeBSD than they do on Linux. So, for example, if I come across, where was it? CRXNG. So what I have here is a Podman container for CRXNG running on Linux, and what you'll notice is here is we've got this stuff like cap drop all, cap add, set GID, set UID, DAC override. So set ID and set GID and ID are like the ID and GID you get running ID. Yeah, so that tells you what group you're in and stuff. But you can't do this cap drop and cap add stuff on FreeBSD because we're running what's called a rootful container. We're running Podman as root. So that's why we have to run do as Podman, whereas on Linux you'd run as Podman. So we can't actually use these options that you could on Linux to change the permissions on stuff. So it's running as root and then drops down to another user. We can't do that. So that's why it took quite a bit of work to actually figure out a way to get all the permissions working so that a regular user, a non-root user in the Podman container could have access to the GPU on the FreeBSD side. And eventually figured it out, and it was incredibly pleasant when you actually get something working. As I said, I had it working as a root user, and then what you do is you're kind of going through and you're trying all these things, and then you type in a command, you press return, and you're going hardware acceleration, and there's no error. So like what's happening was, if you ever worked with this kind of stuff before, what you'll get is CUDA not found OS type error, and I didn't get that, and it worked and didn't throw the error. And then I could come across to the mount directory, play the video. It's got the correct permissions. Is it going to play? Is it just a fluke? Press return, and it only bleeding works. And yeah, that kind of thing makes it all worthwhile. So the thing is, the more you struggle with these kind of things, the greater the sort of sense of achievement is when you actually get them working and you actually proved right in your theories of how to actually get something working. And as I said, there were multiple bits of Lego I had to fit together in lots of different permutations before I got to this stage. But now I've got here the next stage that I know is possible is if we have a look through the README for the FreeBSD jail, what we have here is my old notes on how this actually sort of works. I'm just trying to find the bit where we actually mount the maybe easier if I actually go into the directories. So etc. Jail.conf. So what we have here is the jail.conf where I'm mounting these different directories, and what we actually do is we mount the xdg directory which contains the Wayland socket. So can I list that on FreeBSD? There as, what is it, var run xdg var run, I need to run doas ls just in case. I need to put var run xdg, and you'll see my username. And if I come into here, what you see is Wayland -0. This is the Wayland socket. So what you actually do is you mount this Wayland socket from the host to the container, and then what happens is when you launch a graphical application, an env, there's a Wayland socket list. Okay, Wayland display. So you've got this Wayland display, and what you do is it will see, okay, Wayland display is equal to this. Sometimes you've got to set this in a shell, and what will happen is it will see, okay, Wayland display, I've got to display a window, so I need to use Wayland -0. And what will happen is it will look in the var run xdg directory inside the container. It will find the Wayland socket from the FreeBSD host, and the window will be created and opened on the FreeBSD host. And as I said, what we then have is the home username config.pulse default PA. So this is how we get the audio working. What we have is a default.pa, which would go in .config pulse on the FreeBSD side. And what this does is this includes the default pulse, and what it does is it loads this module called Module eSound Protocol Unix. And what it does is it creates a socket. I've said to create a socket called temp pulseaudio.socket. And then what we can do is we can mount that temp pulseaudio.socket from the FreeBSD host into the container and tell the container, okay, this is where the pulse audio socket is, and that's what gets audio working. So I know how to get Wayland Windows. You can do X11 as well. I know how to get Wayland Windows and a Pulse Audio socket. And what this allows you to do, because we're using a socket for both of these, is you get native performance. There's no latency, no delays. It behaves like a native application on FreeBSD. And this is critical for things like DaVinci Resolve or other graphical applications. So this should allow us to actually take it to the next level and get GUI applications working with Wayland Windows and Pulse Audio. And so you start Pulse Audio on FreeBSD, it creates the socket, container picks it up, the audio is routed from the container, bang, out onto the FreeBSD side. The window pops up with Wayland, you're good to go, you've got video and audio. Can't say fairer than that. And as I said, we've got hardware acceleration. So that's also going to be essential for browsers. So what this means is we should be able to get something like ffmpeg working in a container with a Wayland window, with the audio working, with hardware acceleration, so that you can actually use it with DRM playback. So you'll be able to watch things that require DRM on FreeBSD using a Linux browser, just like you were using Linux. And that's a big win because we've then got the uBlock origin to block all the ads. If you go on YouTube, there are free with ads. So youtube.com, let me just put it in a... Okay. I just want to get to pick up anything. Just want to start with a fresh private window. So YouTube has got free with ads. Free with ads, I think it's called. See if it picks up the right thing. YouTube movies, okay. So what happens in the UK, you get a selection to a few videos. I probably need to be signed in actually. But if you use a VPN, you can actually get a lot more. So let me just see if it's got any. Let me just copy that channel ID. I think I've got to be signed in. Okay, so you can see here, Black Rain, start watching. It should fail. Your browser can't play this video, okay? And what you'll typically see come up is in Firefox, it will have like a little icon saying sort of, DRM. So you can see here, there's, quite a few good free with ads movies that you can watch with a DRM enabled browser. As I said, if you were using Chromium on FreeBSD, the issue is you'd get the ads because you've got uBlock Origin Lite. It doesn't block everything. But good movie, Escape from Alcatraz, classic. That's also a good movie, Night of the Hunter. But that's something else. But I just wanted to show you that Firefox isn't supporting DRM playback on FreeBSD, and the packages that you can install to enable DRM playback on Chromium don't work on FreeBSD, on Firefox, sorry. So yeah, that would be the next step, is trying to get Firefox installed in a container, get the window and audio working, and the DRM. So that'd be the next on the list. But I thought a good place to actually start was actually checking whether hardware acceleration worked for ffmpeg, because that is the backbone of a lot of applications, whether it's something like Firefox, things like WhisperX, or things that use Python Torch. They all use sort of stuff like ffmpeg in the background to do a lot of processing. So making sure ffmpeg works first of all is really important. And as I said, managed to get it working. Took a bit of work, but now I've got that sort of working. What I need to do is actually sort of streamline this kind of process, because what I'm doing is I'm pulling down a sort of Podman container. I'm building the dummy-uvm.so into it, and then I'm installing applications, installing all the bits and pieces. What I want to be able to do is actually build complete containers that are pre-configured and require minimal setup so that you can just pull them down. So there would be two types of containers. One that you would sort of enter to get a shell by sort of running do's podman exec and getting a bash shell inside the container so that you could use terminal commands, run scripts on Linux. And the second type of container that we want is for GUI applications, which you wouldn't enter with you wouldn't use the terminal to enter the container or anything like that. What it's possible to do is to come back to where is it? What it's possible to do while this loads. Freebsd user local should be my bad, home user local share DaVinci Resolve applications. What it's possible to do is actually create a desktop entry that would launch the container, which would have an entry point to run a particular application. So you would have a desktop entry that you would put in local share applications on FreeBSD, would show up in your application launcher of choice. You'd run the desktop entry, and what it would do is it would execute the Podman container, and we'd need some kind of, what I typically do is have some kind of wrapper scripts that starts and stops it, but it would launch the Podman container, open the window, get the audio and everything working, just like opening a native application. So there'd be two types of containers that we'd want. Ones you would actually enter to use a command line application, and secondly, GUI applications that we could actually set up with desktop entries on FreeBSD so that you could just run your application launcher and it would do everything for you. So you'd have it set up. You just run a desktop entry, new application launcher. It would open the window up, all the audio and video and everything would be working. And as I said, because of my previous work on working with jails and the Linuxulator and graphical applications, I know that that's possible and doable, and what the steps are to actually get there, to actually get it working, and that the end goal is to have a desktop application, a desktop entry that you can run so it's nice and user friendly. So what should be possible is to have a repository of images that you can pull down. You would have to do a little setup on the FreeBSD side. Obviously, first you've got to install Podman. You have to set up your devfs rules, but that's not too much work. And once you've actually got that set up, you'd be able to pull the images down and either enter them on the command line and have access to Linux command line applications running with full CUDA support, whether that's something like Alarma with nvenc, not nvenc, it's with CUDA, WhisperX, Handbrake, potentially DaVinci Resolve, or, as I said, graphical applications such as Firefox with DRM, or other sort of applications that aren't available on FreeBSD. We could just create a repository of images, be able to pull them down, and get to work. So yeah, it took a bit of work to get to this stage, but as I said, I proved that CUDA works. I proved that hardware encoding with nvenc sort of works. So those are the two major things, and the third major thing was actually getting this working with a non-root user in the Podman container, because if we're going to be installing GUI applications, we don't want them to be running as root even in a container, because that's a security risk. So the next step, as I'm sort of making my notes as I go along on all this, I've also been making sure to keep the Podman compose file under Git, because there's nothing worse than you try something out and then you think, oh bugger, that's not working, and what was the previous version I did? So always keep your stuff under Git so you can always go back. But yeah, managed to get to this stage. It's a major breakthrough in what's going to be possible, and this is going to open up a lot of possibilities on FreeBSD, where we don't have native CUDA support and we don't have the Nvidia toolkit. And as I said, I was kind of getting to the stage where should I just write them a Nvidia begging letter and say, please can we have CUDA? Please can we have the Nvidia toolkit that we can use it with containers? We don't need it. We can do it natively. We can bypass the big corporations and do it ourselves. And we got the Nvidia drivers, bit of elbow grease, some donkey work, and we've now got CUDA support, hardware acceleration in containers, running as a non-root user in the container, with all the correct mappings, so that the files we create are owned by our user on FreeBSD. We've got the mounted containers so that we can easily transfer stuff from the container to the FreeBSD host, and that's going to be essential for applications that use video processing, things like Handbrake. It'll allow you to select, put video files to be processed in a directory that's mounted inside the container. Bang, you can select them with Handbrake in a GUI application that's actually a Linux application. It will process the files and split them back into the same directory, and you've got access to them on FreeBSD. So yeah, a lot of stuff to cover. Hope it all makes sense. Took a while to get here. And so the next step is looking at other applications. So what I might sort of try is things like other applications I want to try are things like WhisperX for audio transcripting with diarization, in that it will transcribe the audio and let you know this is speaker 1, this is speaker 2, speaker 3. And I actually have a Python script that will allow you to rename speakers to the actual users. So like Bob, Tom, Fred, whatever. So you actually got speaker diarization. So that's something to try, but I've got the command line stuff working. So what I might do next is actually look at the graphical applications. So what I'll do is create a new sort of Git repository to try and get Firefox with DRM working with Wayland window and a pulse audio socket, so that I can actually watch things on ITV and Channel 4, which are DRM encrypted on, the videos are DRM encrypted. So, if you like something like Gogglebox, or you want to watch a film that's on ITV, or something like A Touch of Frost or something, that will be possible. So that's next on the list. So keep tuned though. Won't sort of upload. I'll sort of keep my notes. I'm going to put this actually on GitHub, just because I'm super cautious about losing anything. I like to keep everything under Git just to make sure it's all there. So I'll update the notes, post notes for all this, and the steps that I've gone through, so that you can actually try this out yourself. But yeah, we now got ffmpeg hardware accelerated encoding on FreeBSD using nvenc. So that's a big win. And I said that's important because that's the back end used by a lot of applications, and that's kind of the gold standard of getting things working, and that will then allow us to build upon that and get the graphical applications working, so that you've got browsers like Firefox with hardware accelerated video playback working with DRM, hopefully, as well. So that's, I think, be a good challenge, because now I've done one thing on the command line. I kind of want to sort of focus on something else and then sort of go back to more command line applications. Just keeps the grey cells ticking over a bit. Sort of a new challenge. So yeah, and next step is mounting the XDG runtime directory Wayland socket and the pulse audio socket. So I think I should just be able to actually, instead of mounting the whole directories, I should just be able to mount the two sockets from the FreeBSD host into the Podman container and set the shell up to look for those locations, and that should get the audio and the video working. And then I'll be able to actually try out Firefox and see if I can find a way of, first of all, what I'll do is actually try launching Firefox on the command line in the container with the window and with the video and the audio set up. Once I've kind of got that working, I can then look into getting the desktop entry working, and I'll have to use a script to actually see if the container's running or not. If it's not running, it will start it. If it's already running, do something else, and have it, sort of shut down, or all those kind of different permutations of things that's going to be possible. But just wanted to give you a progress report on how far I'm getting, and yeah, this is a major breakthrough. So next step, GUI applications. That'd be fun. And these videos that I'm recording of actually using nvenc on OBS Studio. So the default settings for local share applications. Yeah, so what I'm doing actually when I'm recording these, as you can see, I'm using the nv-sgl run command and launching OBS Studio, and that's what gets the nvenc encoding working with the FreeBSD version of OBS. And that gets me thinking, you can actually run OBS Studio from a jail, and because we've got nvenc encoding working, we can actually create the issue with the FreeBSD side is what happens is quite frequently the nv-sgl run command can break, and you got a fallback to use like VAPI encoding or software encoding on FreeBSD. So that's another thing that would be good, is actually have a Linux Podman container for OBS Studio with nvenc encoding working. And because I've just shown you that we've got nvenc encoding working with FreeBSD, that means it will work with OBS Studio. And because we have the XDG runtime Wayland socket, you will actually be able to pick windows. You'll actually be able to pick the screens from the FreeBSD side running OBS Studio in a container. Mad as that seems, you'll have OBS Studio have a window open, and you'll actually be able to select the windows. The only thing is, actually thinking about it, is that only works for Pulse Audio. Recording audio only works with Pulse Audio, and a lot of applications use OSS, so I'd have to figure out a way around that. But that's just another thing I was thinking about off the top of my head. And the reason I was mentioning that is because the videos that are created when I record using nvenc are like about 8 gig for 2 hours, so this is going to take me a while to upload. So this is probably going to be uploaded for a good few hours. So if you're about then, in a couple of hours, you'll see this. Otherwise, you'll see it tomorrow. So I'll carry on badgering away at this and taking a look at getting Firefox running with DRM. That'd be a good one. That'd be another good test. And then I can actually look at how we can make these more user-friendly, so you don't have to compile sort of the uvm.so and stick it into the thing. And, you just want to be able to pull down an image and have it sort of pre-configured with the minimum faffing about. So that will be the end goal, but I'm getting there step by step. So I'll put these my notes up on GitHub and update them and stick links to everything, and that's all for now. But yeah, good bit of progress. I wanted to go through everything thoroughly, so sorry for the long video. Congrats if you made it through, but hopefully you kind of learnt a few things along the way about what's actually possible and what's going to be possible in the future. But yeah, this basically means that we can have hardware accelerated video, CUDA support in containers, and not have to keep banging on the fact that we don't have native CUDA support on FreeBSD. Don't matter anymore. We can use Podman with Linux and get around that. And as I've shown you, it works. No mucking about. No, if maybe this, that, and the other. It works. What more can I say? So that's all for now. As I said, I'll upload my notes and stick links to everything under the video.